Yes, welcome you all for the today classes. Today we are going to start a new topic, that is the fluid kinematics. So in this class we are going to start introduction about the fluid kinematics. Okay, so let's start the sub topic. The subject first we should know the what is the fluid kinematics. Okay, then we are going to start the next concept. First, what is the fluid kinematics? So that can be defined in three ways. So first one is the fluid. The subject called kinematics concern the study of motions. So the term first, what is the kinematics? The term it concern the study of the motion. The study of the motion. If you are study the motion of any fluid, then it is called as the kinematics. Kinematics. Okay. So now next, fluid kinematics is the study of how fluid flows and how to describe the fluid motion. So kinematics is nothing but what? The study of the motion. Study of the motion. That is called kinematics. Now, fluid kinematics is nothing but the study of how the fluid will flows. How the fluid will flows and how to describe the fluid motion. How to describe the fluid motion. So to by studying these two, that the term we called it as fluid kinematics. Okay. Now, fluid kinematics deals with describing the motion of the fluids without necessarily considering the force and moments that causes the motion. Okay. So now, in the previous class, we discussed about the fluid dynamics, and here we discussed about the fluid kinematics. The difference between these two are, while in the fluid dynamics study, we are considering force and moments. So these two are responsible for the motion of the fluid. So while studying the motion of the fluid, we are going to consider force and moments. That is called as the fluid dynamics. Okay. While studying the motion of the fluid, we are neglecting the forces and moments. Forces and moments, that is called as the fluid kinematics. So this is the main difference between the what is fluid dynamics and fluid kinematics. In the fluid dynamics, what happens? We are going to consider forces and moments in the study of motion. Okay, but in the fluid kinematics, what happens? We are going to neglecting. We are going to neglecting, or we are not going to considering these forces and moments while studying the motion of fluid. So this is the fluid kinematics. Fluid kinematics is nothing but the study of how the fluid is flow and describing the fluid motion. So in the fluid kinematics description of the flow, this description of the flow can be taken by two methods. We can describe the flow of fluid in two methods. Those are the Lagrangian description method and Eulerian description method. Okay, we can describe the flow of fluid by two methods, Lagrangian description and Eulerian descriptions. Okay, so now first we will study the Lagrangian descriptions. So okay, so here we can take one example, that is a ball on a pool table collides with another ball or with the wall. So Lagrangian descriptions, example for this Lagrangian description is a ball on a pool table collides with another ball or with the wall. Okay, or you can see this this is the Lagrangian method for description of the flow. Here the one particle of the fluid is collides with another particles like this. Okay, so this is the description of Lagrangian description method. Okay, and this if you observe this figure here, Eulerian method, what happens, and at a particular one sections we are going to study is the flow of motion of the fluid. Okay, now Newton's laws are used to describe the motion of the motion of such as objects, that is to accurately predict where they go and how momentum and kinetic energy are exchanged from one object to another object. So here this particle is collides with this particle, and this particle is again collides with these particles. So the collision of these particles, when this collision of these particles will takes place, what happens? The kinetic energy is exchanged from one subject to another energy. The kinetic energy of this particle is exchanged with this particle, and this particle is exchanged with this particle. So, study of these collision of motion of particles can be studied by using the Newton's laws. Newton's laws in the Lagrangian method. Okay, now next, kinematics involves the keeping track of the position vector and the velocity vector of each object as a function of time. So in the Lagrangian method, what happens? We always keep track or motion of this track on this particular fluid flow, okay, or fluid particles. We keep on tracking that position of the particles. This is the tracking of the position of particles, okay. So in this Lagrangian method, next, when applied to a flowing fluid, this method is called as the Lagrangian description of the fluid motion. If the fluid is in motion positions, okay, by applying this method, that is Lagrangian method, is called as the Lagrangian description of the fluid motion. Okay, now Lagrangian analysis is the analogs to the system analysis that you learned in your thermodynamics. Okay, class. Namely, we follow the mass of the fixed identity. Okay, so already this we can analyze in the thermodynamics classes. Okay, now this is about the Lagrangian. In the simple way, we can say that Lagrangian method is keep on tracking the position of the particles which will collapse with another particles. Okay, and also we can apply the Newton's law of motion to describe the motion of the particles of motion, particle of the fluid. Okay, next. Uh, and there is no particular section or element which we are going to study the behavior of the fluid motions, like unlike Eulerian methods. Okay, so this is the Lagrangian method. Now next, Eulerian methods. A finite volume called the flow domain or control volume is defined through which the fluid flow in and out. So here if you observe this Eulerian at this section 1 1 section 1 1, the fluid is enters and fluid is exit from the section 1 1. So that is what we called it is the fixed volume or fixed field or control volume. Fixed field or control volume. But in this case, what happens? There is no such a fixed volume or control volume. So we can keep on tracking. We keep on tracking the position of the particles of fluid. But here, at particular section or identified section, the fluid will enter and exit from that section. That is what here. A finite volume called the flow domain or a control volume is defined through which the fluid flows in and out. So at particular this domain or control volume, the fluid is enters and exit from that section. But here it not happens like that. Okay. We do not need to keep track of the position and velocity of the mass of fluid particles of a fixed identity. Okay, so when the fluid is flowing in a fixed positions or control volume, so we don't need to keep on tracking that particles flow. We don't need to so what we did in Lagrangian method, we keep on tracking that position of the particles, but when the particles moves in a particular field or control volume, so in this case only we are going to study the behavior or description of the fluid flow. So we don't need to track that particles. Okay, now instead, we define the field variables, functions of space and time within the control. And instead of this tracking, we define that field variables like pressure, temperature, and volume. So in this particular section, we are going to define such parameters. Okay. So for example, the pressure field is a scalar field variable for general unsteady three-dimensional fluid flow in a Cartesian coordinates. Suppose the pressure field, if you are going to measure this pressure field, then that pressure field is P is equal to function of positions in the Cartesian coordinates in the x, y and z directions with respect to the time. So the pressure can be defined in a particular section with respect to the positions or directions and the time. Similarly, velocity and acceleration. Similarly, velocity and accelerations. Okay, collectively these field variables define the flow of fluid. If you study these three variables, it will define the flow of fluid. Flow of fluid. Okay. So next, continued the description of the flow. Mm, So again here the Lagrangian descriptions what happens, the Lagrange one must keep track of the position and velocity of the individual particles. See here in this figure. So these are the particles, water particles. So we have to keep track on this individual particles and velocity of the individual particles. These are the velocity of the individual particles. This is what the Lagrangian description. So we are going to study the individual particles velocity and positions. We keep on tracking, okay, while flowing the fluid. Next here what happens in the Eulerian description, one defines the field variables such as the pressure field and the velocity field at any locations and instant in time. So here in this is the control volume. It is having the control volume. Within that volume only we are going to study the field variables like pressure, velocity, okay, accelerations like that. So here pressure x is a function of x, y, z and time in the direction in different directions, three-dimensional direction. Okay, so this is the position of the xyz. This particle position is xyz, and here is the pressure, and this is the velocity. So these two are can be defined in a control or fixed volume. Control volume. But here we don't have any such a control volume or a fixed field, so that we can keep on tracking the each and individual particles and also define the velocity. But here in the within the control volume only we are going to study the behavior of the fluid particles. Okay, so this is the differences. Okay, next, types of the fluid flow. Okay, there are some types of fluid flows there. So description of the fluid flow is takes place by two methods. One is the Lagrangian method and another one is the Eulerian method. But next is types of the fluid flow. So there are total 7 types of the fluid flows are there. So those are steady flow and unsteady flow, informed flow and non-informed flow, one-dimensional, two-dimensional and three-dimensional flow, compressible flow and incompressible flow, ideal flow and real flow, laminar flow and turbulent flow, rotational flow and irrotational flow. So these are the types of the fluid: steady and unsteady, informed and non-informed, one-dimensional, two-dimensional, three-dimensional flow, compressible and non-compressible, ideal and real, laminar and turbulent, rotational, irrotational flow. Okay, now discuss it one by one. Okay, first one is the steady flow and unsteady flow. Fluid flow is said to be a steady if at a point in the flowing fluid various characteristics such as velocity, pressure, density, temperature, which describe the behavior of the fluid in motion, do not change with respect to time. So, if the fluid flow is said to be steady, so what happens? These characteristics like velocity, pressure, density, and temperature will not change with respect to the time. If the time changes, but these property will not changes. What are those properties? Velocity, pressure, density, temperature. Okay, so these parameters will not change with respect to the time. So such flow is called as a steady flow. Okay, so that can be expressed in mathematically. Dou by u by dou t is 0, dou v by dou t is 0, by dou t is 0, and dou rho by dou t is 0. Okay, rho by dou t 0, like this. So if the time changes, so the properties of the fluids like velocity, pressure, density and temperature will not change. So these properties will remain constant. So such type of fluid flow is called as a steady flow. Now next to the unsteady flow. Okay, if at any point in the flowing fluid any one or all the characteristics, what are those? Velocity, density, pressure, temperature, which describe the behavior of the fluid in motion, change with time. So here these properties, pressure, temperature and density, will not change with respect to the time in this unsteady flow. So these properties are changes with the time. If the time changes, the property of the fluid will also changes. What are those properties? Are characteristics, pressure, velocity, temperature. So such type of fluid flow is called as a unsteady flow. Unsteady flow. Okay, steady flow is nothing but the properties will not change with respect to time. Okay, if you are take an example, pressure at uh, pressure uh, pressure P is on 10 bar at 1 o'clock. Okay, if you are checking the pressure of the fluid flow at 1 o'clock, time 1 hour. Okay, so after 1 hour, that is 2 o'clock, if you are going to check the pressure, it remains shows the constant value. It remains shows the constant value of the fluid flow. So such type of flow is called as the steady flow. But in this unsteady flow, if you are measuring the pressure at 1 o'clock, it shows the 10 bar. The same fluid flow motion pressure can be observed after 1 hour. After 1 hour, say 2 o'clock, then if it shows the 10, below 10 or more than 10 bar, then it is called as an unsteady flow. That means what happens? The pressure will not constant. Okay, with respect to the time, that is called as an unsteady flow. Next one is the informed flow and uninformed flow. See here, if you observe this figure, we will come to know what is the informed flow and uninformed flow. When the velocity of the fluid flows does not change both in magnitude and direction from point to point in the fluid flowing for any given instant of time, the flow is said to be informed. That is mathematically dou v by dou s is equal to 0. See here, the flow between two parallel plates. Here, the flowing fluid will not change its directions. It's showing its directions is not changed. It's flowing in the same directions, and also it will not change its magnitude. That means whatever the pressure is there at this section, the same pressure is here in this section. Okay, it will not change its magnitude as well as the directions. It shows it is flow in the uniform directions, uniform cross-sectional area. But here, non-uniform flow, if the velocity of the fluid flow of fluid changes from point to point in the flowing fluid, at any instant the flow is said to be non-uniform. Mathematically, dou v by dou s is not equal to 0. That means what happens here? If the cross section will changes, cross section will changes. Okay, so what the pressure at this point is different and pressure at this point is different. It changes its directions as well as the magnitude. Magnitude is nothing but the pressure at this point is different than this pressure at this point. That means the magnitude changes, and also it changes its directions. It is not flowing in the same directions. Okay, so this is what a non-uniform flow. Okay, it changes its magnitude as well as its direction, then it is non-uniform flow. Next one is the types of flow discontinuous, steady and informed flow. So example here, flow of liquid through a long pipe of a constant diameter at constant rate. Flow of a liquid through a long pipe of a constant diameter at constant rate, that is called as a steady uniform. Steady is nothing but it is flowing in with the same velocity or pressure, that is not changed with respect to the time. That is what steady, and uniform is nothing but here constant diameter. The diameter of the pipe is not changed, so that it indicates that its magnitude and the direction is remains constant. Okay. Now, study non-uniform flow through a tapering pipe at constant flow rate. The flow rate is constant. That means the pressure is constant, but it is flowing in the tapering pipe. Tapering pipe. That is steady non-uniform flow. Okay. Unsteady uniform flow is a flow through a long pipe of constant diameter, that is uniform flow, constant diameter, uniform form, at either increasing or decreasing the flow rate. See, that is what unsteady. The flow rate is changed with respect to the time, then it is unsteady, and the flow is flowing in the long pipe, then it is uniform flow. Now, unsteady non-uniform flow, that is flow through a tapering pipe at either increasing or decreasing the flow rate. So these are all coming under again the classification of the fluid flow in steady and uniform flow. Okay. So if you observe this example, we will come to know what is the steady flow and uniform flow. Okay. With this, we are going to stop. We are going to end this class. In the next class, we are going to start the another types of flow, that is one dimensional, two dimensional, like that. Okay. And okay, next class we are going to start the another types of fluid flow. Thank you.